Engineering Academy. How do we ace in Cambridge or Oxford interview? Well, this is all about it. You first need to ace in the graph sketching. This video is all about the method you will use in the Oxbridge interview. But first, let me introduce you to the universal method. It can solve for any kind of graph sketching, but somehow it is slow, but it is always useful. The first step is to find the domain and its nature of the function. However, this step you don't need to waste a lot of time to prove something. For example, if you say a function like this, at the first glance, you will see that x has to be greater than 0. So you know that the domain is x greater than 0. If you have a function like this, then you will realize that its domain is x greater than 0 while x is not equal to 2. So you can always find the domain at a glance. And what about the nature of the function? Well, it includes whether it's an odd function or an even function. What's the point of finding that? It can reduce your workload when sketching a graph. For example, if you see a function like this, fx is equal to the x to the power of negative 2. At a glance, you will find that it is an even function, which means that for the positive axis of x and the negative axis of x, it is the same. It is just flipped by the y-axis. For example, the graph will look like this, and it is symmetric to each other. So, at a glance, all you need to do is to find its domain and the nature of the function. You may like to write down the domain like this. Now, the second step is to plot the point. You might think this is really stupid to do such thing, but actually, if you do that, it will be really helpful for you to sketch a graph. Sometimes you don't need to do even further step to find the graph. Well, how do we do that? We want to find the value when x equal to 0, y equal to 0, when x approaches the positive infinity and the negative infinity. This is the 4-point we're trying to find. However, you can actually find more points such as x equal to 1, x equal to 2, and that doesn't matter. Somehow, we like to focus on one more thing, that is when y approaches positive or negative infinity. So what does this 2 means? Well, this when y equals to 0, it means it is a 0 point, a 0. And what does this mean? Well, means it is an asymptote that when x approaches this point, y approaches infinity. So most of the times it is not defined on this point. So when you see a point that is not defined and its near region is all defined, then it will probably be something like this. And the third step is to find the stationary point. Which means df over dx is equal to 0. Which means that at this point, it will not change. It is flat. And most of the times, we don't have to come to this step to find the graph. So now let's see some examples. Let's see how do we sketch f is equal to ln x over x. First step, domain and the nature of the function. You will know that the domain is x greater than 0. So they only have the graph on the positive axis of the x-axis. Then you can now draw the coordinates x and y. And now you want to find the zeros. So when ln x over x is equal to 0, x is equal to 1, right? So at this point, it is 0. So when x is 0, what is the value? Well, when x is 0, it is actually not defined. So when x approaches 0, ln x actually approaches the negative infinity, and x is actually equals to 0. So it is a infinity divided by a 0. It is approaching negative infinity. So you may want to put a cross like this. And then you want to know when x approaches the positive infinity, what is its value? Well, ln x is approaches infinity, and x is also approaches infinity. So now we will use the L'Hopital's rule. Ln x over x, the limit when x approaches infinity, it is equal to, we take the derivative of both. Well, this one is 1 divided by x when x approaches infinity, so it is 0, right? Now, we put a cross here. I may extend this x-axis. I will put a cross here. It means it passes this point. So now, actually, you can already sketch this graph. Well, we have to go through these 3 points, and since there is no more zeros, you cannot pass through the x-axis like this. So it can only be graphed like this. And after you finish this, you find your graph is correct. So you don't actually really need to proceed to the next step, but if you want to, you can actually find the point of this stationary point. Let's see. F is equal to ln x over x, and f prime is equal to ln x prime times x minus x prime, which is 1 times ln x, divided by x squared, which is equal to 0. Ln x prime is equal to 1 over x. So 1 minus ln x is equal to 0. So ln x is equal to 1, x is equal to e. So at this point, it is e 1 over e. And this point is the stationary point. So now you get the whole graph. Let's see another example. Let's say fx is equal to 1 plus x, 1, x minus 1, divided by x minus 2, x minus 3. So first, at a glance, you will, this is actually a special kind of function, but let's do it the same way. At a glance, you will find that the domain is x is not equal to 2 or 3. And this function does not have any nature. Let's put a coordinate here, x, y. 2 and 3, those are not defined. And remember what I said, if there are points that are not defined, it means that there is probably a asymptote. Well, what are the zeros? When x equal to 1 and when x equal to negative 1, it is a 0. You may like to find out when x is 0, what is the value of f. f0 is equal to 1 times negative 1 times negative 2 times negative 3, which is negative 1 over 6. So it is here. In this kind of question, we also want to know in each section, here is a section, here is a section, here is a section, what is the whether the value is positive or negative, because you can see that every section it is divided by whether a asymptote or a 0 point. So for every section, it is good for us to find out whether it is positive or negative. First, because when x approaches infinity, all of those values are negligible. So the sign of x give us that it will be positive. However, when x is smaller than 3, here is 3, here is 2, here is 1, here is -1. When x is smaller than 3, this term turns into negative. So this will be negative, and this will be positive. There will be negative, and there will be positive again. So we can actually sketch this graph. Since it is positive and reaches infinity, it is here, like this. Here it is negative and this. It came from positive again, and it crosses this 0, and it became negative, and it crosses this point and goes out like this. So now you get the graph of this function. Let's see a final example. X to the power of -1 minus x to the power of -3. Now, for the domain, you can see that clearly x is not equal to 0, and for the nature, it is actually an odd function, because f minus x is equal to negative fx. Now, you put down a coordinate. This is x, this is y. It's time for us to find whether what is approaches when x equals to 0, y equals to 0, whether it's at 0, or x approaches positive infinity, x approaches negative infinity, and when x approaches infinity. So when x is equal to 0, it is actually not defined. And both of them is approaches infinity, so we cannot say anything about that. But if we come from the right side, now, since we know that it is an odd function, let's only consider when x is greater than 0. So when x approaches the 0 plus, what will be the function approaches to? Well, f is equal to 1 over x minus 1 over x cubed. Let's make one of that. Let's make it look like this. This term, it approaches negative infinity, and this term approaches infinity. So an infinity number times another infinity number approaches infinity, right? So let's put a point here. When y is equal to 0, then f is equal to this, and actually the same on the above. It had to be 0. What does it mean? Well, since this term cannot be 0, then 1 over x squared is equal to 1, which means x squared is equal to 1, x is equal to positive or negative 1. So we have a 0 here, 1. Now, what happens when x approaches infinity? Well, f is equal to 1 over x times 1 minus x squared. So when x approaches infinity, this term approaches 1, and this term approaches 0, so it approaches 0, right? So put a thing here. Now we actually see how the graph goes. It goes like this, and it approaches 0 when it goes to the infinity. And also, don't forget it's an odd function, so you have to draw when x smaller than 0. It is like this, crosses -1, and then approaches 0. And you will find that you finish that. You can put this function into a graphing calculator, and you will see that it is actually the same. Now, let's talk about one more thing, and this is other than the universal method. It is called the graph moving. It is faster than the universal method when it seems really simple when the expression. Then you can try to consider this kind of thing. For example, if you are graphing a function like f is equal to 1 minus 1 divided by 1 over x, then how do you do that? You can first graph the 1 divided by 1 plus x, or you can just graph this, and then you move to this, and then you move to this. First, we know how to graph a 1 divided by x. It looks like this. Then how do we graph an 1 divided by x plus 1? Well, this is moving the graph to the left for 1. So it looks like this. This is -1. Then how to graph 1 minus this? It is actually just flipped upside down. Notice that it approaches 0 in this graph. So when it minus by 1, it approaches 1, like this. Since it is flipped, well, it will go like this. And this is the asymptote of -1. This is a asymptote of 1. You want to know that what is the value of at 0, because it is important at this point. So f0 is actually equal to 0. So you need to adjust this graph a little bit. So the graph looks like this, and you did that. This is the two methods of the graph sketching. One is the universal method, the other is the graph moving. Hope this will be useful for you, and thank you.